So let's talk about disjunctions. So the disjunction is just the word or in English, right? And it's pretty much universally just represented by the lowercase letter v. So I'm just going to cover how the variants that you find, right, in English that are all disjunctions, and talk about what a disjunction is, right, what it means in natural language, what it takes for it to be true. Then I'll offer up a truth table so that we can see how it is that the disjunction actually evaluates in statement logic. And then finally, I'll offer you a formal definition. Okay, so first, let's talk about those variants, right? So or and either or are really the only variants that you're going to spot. There aren't that many ways of expressing that one or the other thing is the case. And in natural language English, right, an or statement is going to be true when either one or the other of the disjuncts, right, which are just the components of a disjunction, turns out to be true. It doesn't have to be the case that both of them are true, right, in order for it to be true. That just tracks, right? So just to use an example, if I went ahead and I said that tonight I'm either going to watch a movie or I'm going to read a book, if it turns out that I didn't read a book but I did watch a movie, I told you the truth, right? You wouldn't accuse me of lying. Just as well, if I did the opposite, you would also consider that to be the truth. Interestingly, if I did both, oftentimes we will consider that to be true, but not always. And I'm going to touch upon this in just a minute, where we talk about the exclusivity or inclusivity of disjunction, that in natural language doesn't quite work the same way that it works in formal logic. But let's go ahead and write up the truth table for the disjunction. So P, Q, P, or Q. So first we'll go ahead and we'll fill out all of our truth values the way they're supposed to be filled out. True, true, false, false, true, false, true, false, right? And if this is your first time seeing this, I recommend that you watch my video on how to set up truth tables in order to understand why that's how you set these things up. But okay, so this covers every single possible combination of truth values. We're now ready to evaluate. So I'm going to write up the way that this evaluates, and then I'll explain more about the inclusivity stuff that I said earlier. So this would be, if both of these are true, this evaluates to true. If one of them is true, it evaluates to true. The disjunction evaluates to false only when both disjuncts are false. Okay, so here's the inclusivity stuff. In formal logic, a disjunction is always inclusive. What that means is, even if both disjuncts are true, the disjunction will always evaluate to true. This is not the case in English, and that's because in English, context sometimes makes a disjunction necessarily exclusive. So for instance, it's either on or it's off. That's an exclusive disjunction, right? What's known as an exclusive or. So it can be on or it can be off. It certainly can't be both, and it can't be neither, right? There are ways of representing that in formal logic, where you just add some more stuff. I'll talk about that in a later video when we're doing proofs and when we're evaluating truth tables and stuff. But the thing that I want you to know about this is just that in logic, just as a rule, remember that disjunctions are always inclusive. So every single time you see a disjunction, if both disjuncts are true, then that means that the disjunction is true. And in fact, when you're transcribing, from a natural language English sentence to formal logic, you're going to have to be careful about this, because if you saw a sentence in natural language that said it's either on or it's off, this would not be the right way to represent it, because that's an exclusive or, right? In fact, I'll just go ahead and show you how you would write that. You would say, let's say that A stands for it's on and B stands for it's off. You would say either A or B, and not A and B, right? And you don't have to, if this is completely new to you or something, that's okay, right? This is just to show you that there's a specific way that you represent exclusivity. When it comes to disjunctions, you have to explicitly state that it can't be both. It's okay for it to be one or the other, but not both. All right, and now I'll finish off by giving you a definition of what a disjunction is and how it is that one evaluates one in the truth table. So here's a definition. A disjunction is false if and only if both of its disjuncts are false. Otherwise, it's true. Notice that this definition covers exactly what this truth table says. It tells us it's false under only one condition, that both of these are false. Under every other condition, the disjunction turns out to be true. And that's everything there is to know about disjunctions, at least for now. Stick around for more videos on exactly this topic. See you around.